well.
You.
Okay, so
Oh no! Oh no! Dive! Oh.
Evan, your mic's on, buddy.
Yeah, please do mute your mics. Okay, so for the homework, the TA was actually telling me that not all the groups are getting equal opportunity to consult the homework problems with him based on how the schedule has been made. So he suggested that we delay the homework deadlines to the following Monday. That would give all the groups enough time to work with him on if they have any questions on the homework. So the homework 2 and 3, which were due today, they're instead due on Monday. And I did not want to make it due on Monday morning because you guys might have other things. So it's due on Monday night. And then onward, the subsequent homeworks would be due on the following Mondays. Let me see if I can mute you guys. Okay, so I'm muting everyone, but if you have to say something, you can unmute yourselves and then talk to me. Okay, let's try this out. One of you say something to me.
Hello.
Yeah, so this works. So unless you unmute yourself, everyone else is automatically muted now. Anyway, so this is the homework schedule. Things would be due. You typically have more than a week on each of the homeworks to work on. So the homework that's going to be announced at the end of the lecture today is going to be due 11 days from now on the Monday of the following week. Okay, so do you have any questions on this? So hopefully this should give you enough time to use your lab sessions to get your homeworks done as well. Okay, so let's move into the main lecture. So where do we stand now? We have, in terms of the overall syllabus, we have done basic calculations on MATLAB. We have done vector operations. And in the last class, we learned how to write, first we learned how to write script files. And then we learned how to write function files. And both are the main subtypes of any kind of MATLAB code. So now we know how to code on MATLAB, relatively simpler codes. So the things that we're going to do in this lecture and over the next 2 lectures is learning new tools that can help you build a better code. And with the previous lecture and these 3 lectures, you should be relatively ready experts to write code on MATLAB and solve any kind of engineering problem. So let's look at this first tool, which is the if statement. Well, before I come to the if, the generic thing that we are going to learn over today and over the next 2 classes is this control flow logical structure. And what it means is if you have a computation that you have to do multiple number of times, you don't do it repetitively by hand. Rather, you'd want the computer to do it. And you can make the computer do something multiple times by embedding this kind of logical structure into your code. So as the name suggests, if means that you are going to tell MATLAB that, okay, if this is true, then do that other mathematical operation. So basically you are going to control MATLAB, what it does by setting some kind of condition into the program, which MATLAB is going to check. And as long as that condition is true, it's going to carry out a certain set of operations. If that condition is not true, it's going to carry out a different set of operations. But the bottom line is still the same. You are trying to make computer work more. And you do that by setting this kind of logical structures inside your code. So there can be different types of this kind of control flow logical structures. In this class, we are going to learn for, while, and then if. These 2 are for the next 2 lectures. So for the lecture today, we are going to focus just on the if structure. And as I have written down over here, this is the generic layout of operations when you are trying to embed an if structure into MATLAB. but we are going to do more examples, and that should give you a better sense of what I mean. Okay, so let's start writing the code altogether. So the first lines for the code would be clear all, close all, and CLC. And in terms of the question that we are going to solve here is this. So suppose we have two different numbers. Suppose I is 3 and j is 10. Then based on what values of I and j are plugged into MATLAB, the program would output a different variable m. I know it's kind of a vague, but for the first problem, I just want to check if we understand how if works, this if structure. So it says that, okay, we know some values for I and j. Let's plug those into the code. So I is 3 and j is 10. Now let's write a subcomponent under this code, which would check these values of I and j, and based on the conditions that I'm going to tell MATLAB, it's going to shoot out different kinds of values for the third variable m. So let's directly dive into that if structure. So if I is greater than j, then suppose, which in this case is not true, but we are going to come to that later on. Suppose if I is greater than j in a different wall, then m is some number 100. So that's the first condition I told MATLAB. Elsif. So Elsif is the thing that you are going to use for the second, third, fourth conditions. So Elsif I is greater than 4 and j is equal to 10, and we're going to revisit all these things in a matter of moments, like why I wrote 2 ands and 2 equals. But this, in regular English, this means that I is greater than 4 and j is also equal to 10. Then that third variable m should be assigned a number of 200. And for the final condition, we use else. So we can have as many subconditions as we want with else ifs and else ifs like this. But if we don't have any third condition, fourth condition, but we are just left with 1, 2, and 3, then we close this loop with this else. So if these two conditions are not valid,
We can't hear you.
can you hear me now?
You're back.
Yeah.
Okay, so where did we leave off? Where was I? Did you listen to any part of this code?
Right after like the m equals 200, I think.
Okay.
Yeah, you were deleting the two else's.
Yes. Okay. Okay. So if you have multiple conditions over here, you can use as many else ifs as you need to, but the last condition should just be an else, and that's when you are done with all the other conditions. So there is no condition following this else, and if those first two conditions are not true in this case, then let's assign m is 300. This is just a fictitious example to show you how this works. And then we end this if structure with an end. Okay, so let's save this and see how this one works, and then we are going to do a few more things on this code, because right now it's kind of meaningless because you already know that I is 3 and j is 10. So of course you know what is m. Over here m is going to be 300 because I is greater than j is not right as per the assigned values of I and j, and this is not right either because j is 10 but I is not greater than 4, I is just 3. But let's save this for now. So this is 2020 let 5 code 1. Okay, and this is a script file. I can just run this, and so it has run the file. Since I have semicolon after the m's, it's not going to give an output straight away, so I need to press m and then do an enter. And as I said, it probably should be 300, and so it is 300. So this kind of did not make much sense anyways. But if we rather have something like this, input enter I, and then for j, input enter j, and that backward slash and n is again for the control to go to the next line when MATLAB asks you that question. So let's save this and let's see how this one works. So if I now run this code, it asks for enter I. So let's try out. Okay, someone suggest me a value for I.
5.
5. Suggest a value for j.
69.
Okay, so what do you think the output m should be based on 5 and 69?
I think it should be 300.
It should be 300 because I is not greater than j. I is greater than 4, but j is not 10. So the only other third condition that we are left with is still 300, and 300 it is. Now again, let's run this, and let's imagine that I is still 5, but let's put a smaller value for j, and then if I press m, it should give a different value for m because now the first condition is true, I is greater than j, so m is 100. On the other hand, again, let's run this, and if I have I to be 5 again, but j is just 10, we get the second output, which is m is equal to 200. So see, this might be a very simple example, but this is beautiful. You can use this to figure out which part of the calculations you want to run based on different constraints on the engineering problem, because this is just a simple one single line of mathematical operation, but you can add as many complexities you might want under each if or under each else if. And to show you again the overall structure, there is no condition that should follow this else. So you come to the else line when you have run out of conditions. So suppose I can add another condition over here, else if I equals j. We have not really covered that in the first two conditions. If I is equal to j, then press m is disp I and j are equal. So this is another thing that you just learned, how to give an output, like sort of like a line that would prop up when you run this code. So let's see if this one works. So save this and then run this, and then enter I 10, enter j 10, and then type m. Okay, this did not work out the way I wanted. I is greater than 10. And okay, it did not because, okay, can someone suggest, explain to me why it did not work? Because I was hoping that since I is 10 and j is 10, we should get this output, I and j are equal. But we did not, we got 200. Why was that?
Is it because we have an Elsif line where if j equals 10, m will output 200?
Yes, so when MATLAB was running its brain through this code, it first encountered this line. And this condition is also true for this 10 and 10, right? So it did not even go to this next line. It just saw that I is greater than 4 and j is equal to 10. So this is the output that the guy wants. So this is not the best inputs for 10 and 10 to get this third m. So let's try something else. So let's try m is equal to 5, I is equal to 5, and j is equal to 5. And we get an error. I think the error is because of this. So let's do this. So this is related to how I use the display command. So let's try to debug this and just run it again. I5, J5. So yeah, you cannot assign display to a certain variable. You can just make MATLAB write out that line, but you cannot assign that line to a variable. So now I is 5, j is 5. MATLAB came to this line, saw that they're indeed equal, and none of the other conditions are true. So it displayed this line, I and j are equal. Okay. Any questions? Okay, so this is a very basic example, and I think I have added a few more lines to the screenshot that I have over here, but yeah, you'll have the video lectures as well. So just follow the lectures and you can build your own code based on this generic structure. So let's come to the lecture notes now. Okay, so I have written down why we need this kind of logical structure. For example, we are going to do some similar, very simple examples later on today, but typically in engineering systems, we tend to use different kinds of equations based on certain conditions. So if the condition is XYZ, we use this set of mathematical operations. If the condition is something else, ABC, we use another set of mathematical operations. And you can control that by using this kind of structure where you add all those mathematical operations under each if or under each else if. Okay, so in this slide, I have written down a generic structure of how all functions are in MATLAB, and if is nothing but a function, but it's an inbuilt function that MATLAB would use. And we know how to set up functions. So that is not new to you, like this first line. But what I'm trying to press on here is if is just a function that's inbuilt into MATLAB, which you are not building yourself, but something that you can use anywhere and everywhere. Just like we learned in the last lecture that once a function has been built by you, you can use that function in some other code as well. And that's the beauty of developing functions. Okay, so let's focus on the slide again for now. So as I said that I'm going to come back to what these signs imply. So for example, the first couple of things are self-evident. So this is less than, this is greater than. If it is less or equal, then you use this sign. If it is greater or equal, you use this order. You don't write the equal first. You write the greater than symbol first, and then go to the equal. If two numbers are supposed to be checked, if they're equal, then you use two equal signs, not one single equal. And if they're unequal, you use this wavy symbol and then an equal. So just remember this shortcuts that you have to assign the logical operators into your conditions. Okay. The other thing that we saw in this code is double use of the AND. So this means that both the conditions, which in this case was I greater than 4 and j is 10, both the conditions are supposed to be checked by MATLAB. And for that, you use the AND operator, whose syntax is these two double AND signs. But if it is OR, that means if this is true or the other one is true, then you use this sign. So let's try this one out if all works. So let's do this, and let's change this to 0, and let's take this line out. So now if I is 5 and j is 2, your m is the first option, right? Because 5 is greater than 2. But if I run it again and I type I to be 0 and j to be 10, what do you think the output is going to be? Someone?
200.
300.
It's actually going to be 300. It's not 200 because this, I said, is the OR operator. So when I assign that both I is 0 and j is 10, it's no longer true, this condition, because both are true. So it's going to go to the next line. But if either one of them is true, then it's going to give m to be 200. So let's just check that out. So, okay. So this is something new to me as well. So it gave m to be 200. So I think the way the logic worked here, it just checked something and then laid out the output. Let's try a few more things on this code then. And I hope you guys are working with me as well. So if you have an answer, just you can speak on the mic. Okay. So this means that either can be true for the entire statement to be true. Yeah, so whoever was the first student to respond was actually true. And I was wrong, I think. So if this is true or this is true, then we get m is equal to 200, which is what we got. We did not get m is equal to 300. On the other hand, if we had and let's save this and run it again. And if we have I is equal to 0 and j is equal to 10, then the m should be 200, which is true. But if it is this, and then run it again, and then we use I is equal to 0 and j is equal to 10 again, we still get m is equal to 200. So this means that, okay, this is something new to me as well, that probably when you write your codes, this OR operator might not be that useful when you have a problem this simple. Because then it is just going to check one of the statements, and as long as it is true, it is just going to shoot it out. But this might be useful when the overall logic of the problem gets more complex than what we have here. So for this one, let's just go back to the code that we had before. So I is greater than 4 and j is equal 10. Okay, any question on this one? Okay, so you can use the symbols, this logical operator symbols into your conditions and make sure that you use them correctly. The ones that I want to highlight out is this one. Make sure that the order is right. So first the greater than sign and then the equal. And then this one where not equal means this vinculum and then equal. Okay, so we have more details on the if statement here on these slides. So just read through them when you prepare for the homeworks or for the tests. There can be 3 different subtypes of if, and what we actually did on this code is the most complex one, where we have the if and then we also have an else if and then we have an else. But the simplest one is if end, where there is just one condition. If this is this, then output that, and then you directly go to the end line. The next is if there are just 2 conditions. So if this one is true, then give some output, else give the other output. or if this is the most generic one, where you have more than two possible outputs. Okay, so this is some schematic diagram that I included to hopefully help you understand what is going on here. So if it is just, as I said, an if end, so this is what happens in the flowchart. So there is the if statement followed by a condition like this. So if that statement is true, then it carries out the commands that will follow that if. But if it is not true, it would directly go to the end and exit the loop. So let's think about a very simple code on those lines. So we don't really have to deal with a second variable here, and just j and just I, and suppose this is the structure we have. So just one output and then an end. So this is what I mean over here. And then let's make it a little bit complicated to show that we can add multiple lines under this loop under each if statement. So let's save this. So this is lecture 5, code 2. Okay, so let's run this. So if I have I to be something less than 5, so what happens then? So that means that once it encountered this line, which is, as per the condition, is I greater than 5, it just, as per this flowchart, it did not carry out these mathematical operations. It went directly to the end. So this would imply that it doesn't really know what M is or what A is. So let's check that. So let's type M. It doesn't know what M is because it never managed to go to those lines where M was assigned. And it should not also know A either because it did not go to those lines. But on the other hand, let's run this again. And if we type something greater than 5, say 7, then it knows what is M, because now this condition being true, MATLAB's control actually went to these lines and assigned 100 to M, and then it would go to the next line as well, and A is 101, which is as per these calculations that I have asked MATLAB to do if this condition is met. So this is the simplest structure of if, and I hope it is easy enough to understand. As we go to more complex algorithms, you have the next version, which is if, else, and end. So let's work on that on this code. So if I is greater than 5, then A is M is equal to 1, else A is M plus 2. So let's see what happens now. So if I run this, it's again going to ask for I. So let's type, suggest some value for I, some of you. Anyone, give me a value for I.
11.
34.
3.
Okay, 11, 3, and 34. We'll try all of them out. So let's start with 11. So M is 100, A is 101. Fine. But if we have I to be 3, so to do that, let's run this code again. And I is 3. We get this error. And why is that?
Oh, shit.
Why did we get
Because
this?
I is not greater than 5.
My bad.
I is not greater than
Because
5, but still.
M isn't a variable if I is less than 5.
Yeah, I think you're right. Since I is
Oh.
greater than 5, it doesn't really go to these lines where we had assigned M. So it goes directly to this else line. And then while calculating A, it doesn't really know what M is, so it cannot compute A. So be cautious about this kind of errors. So for example, if based on the condition it would not go to this line, so you need to possibly assign M again. Or if there is a different value of M you want to use for that different set of calculations, you assign that value over here. So you need to understand what the logic is, what is the story you want to tell MATLAB, and set up your code accordingly. So if I type it now and just use the other value of I that was suggested, 34, then we would have A to be as 100 plus 1, which is 101. But if I rather use something less again, for I less than 5, say 2, then we have M as 100 and A is now 102. So now it knows what M is because I have added this one line over here, and it can compute A. Okay, so let's go to the next option, and this is what we already did in the first code that we developed today, where you have an if statement. Then there is a comments group 1, which is this line here for us. If that is not true, if this if statement's condition is not true, it goes to the false arrow and comes to the Elsif. And if that is true, it carries out the comments group 2, which in this case was this part. If this Elsif statement is not true either, then it again goes to the comments group 3. And then there is no condition after else. It just carries this one out and then exits the loop. So this is the overall structure of if statements. Okay, so let's solve another example. So first we are going to learn something new that MATLAB has as an inbuilt function, and then we are going to develop a similar function of our own. So the sine function on MATLAB, it actually gives you the sign of a number. So if the number is greater than, if the number is positive, it tells you that the value of sine. So suppose let's try an example. If the number is say 21, it gives an output of 1. So this implies that if the number is positive, the output is 1. If the number is negative, so if it is minus 21, the output is negative 1. And if the answer is 0, the output is 0. And this works for small numbers as well. So if the number is negative but very, very small, suppose this, the output should still be negative 1. So this sine is a function that's already inbuilt in MATLAB, which I'm sure that you are going to use at some point. The question here is, develop an M file to perform the same operation as the sine function above. So we are going to first write a script file that's going to do the same function do the same operation as this sine. So let's do that. And we are going to write both a script file and a function file for this operation here. So someone tell me what, so we are writing the script file for this question in yellow. So someone tell me what should be the first lines on my code.
Close all clear LCLC.
Yeah. So the question is, we are trying to check the sign of a number, if it is positive, negative, or if it is just 0. So this is the overall question. Now, as you guys should know by now, there are multiple ways to solve the same question, because essentially you are telling MATLAB to do a certain thing following a certain logic, and that logic can be slightly different for each person. But someone suggest me what should be the first thing that we should do here.
I equals input.
I is equal to input, and what is I here?
It's just the number.
It's just the number that you were trying to check, right? So enter the number. Okay. So since we are trying to learn if, we are of course going to check the number using the if structure, as in what is the value of the number, and then have the output accordingly. So if, what should be the first condition?
I is less than 0.
If I is less than 0, what should be the mathematical operation here? So let's do something like this. If I is less than 0, let's name a new variable my sign. What should be the output for this my sign? So we are trying to replicate this sine function. So if it is a negative number, then it is -1. Say again. -1, because we just want to recreate what we have over here. Okay, so all good. So if I is less than 0, this is the condition. So should we directly go to else, or should there be an else if?
Should we do an else if I is equal to 0? Just kick out 0.
Okay. Then my sign is 0. Should anything follow else? So of course the third condition that is left is I greater than 0. But should we write that out over here, or should we not?
I shouldn't.
You should not, because else does not come with a condition, and based on these conditions that we have chosen, we have covered all other possibilities. The only possibility that is left is I is positive, and you don't really need to tell MATLAB that. So else my sign is 1, and then end. So let's save this. So if I run this, use parentheses. Okay, so there was a typo here. So let's save this again and run this. Okay, enter the number. So let's type out a negative number first. Let's type -10. My sign is -1. Fine. Let's run it again, and then let's type 0 for the number. And my sign is 0. Let's run this again. And let's type a positive number, 50. And my sign is 1. So the logic worked. It doesn't really matter which order you maintain for your conditions. You can as well put this as the second condition, and then the only other option that would be left would be I is 0 as the third one, where you don't really need to state the condition explicitly to MATLAB. But that depends on you. So just try to think of it as a series of information that you want to pass on to MATLAB to do the calculation. And you don't really need to memorize any code. Just try to think what the problem is asking for. Any question on this one? Okay, so this is a script file. And the problem with the script file is, as you saw, that every time we need to run the thing to get this question out, right? Otherwise, it cannot really run twice. But what is more useful than script file? It's the function file, where once you have written the function, you can use any number of times. So let's try to adopt this, but transfer transform it into a function file. Okay, so for a function file, what is the first step that we are going to do? What is the first thing that we do to write a function file on MATLAB?
Don't you have to go to the function button under new?
Exactly. So that's the easiest thing to do, function. Fine. So now let's think about this problem and let's think about the syntax on function. So what is the output here? So when you write out the function file, the first line should have first the output argument and then the input variables. So what is the output for this code?
My sign.
Okay. My sign. Good. What are the inputs?
I.
I. So here we are trying to replicate the functions of the inbuilt sine function. Okay, so we need to name it accordingly as well. So let's name it fall 2020 code 4. 5 code 4. Okay, so all good. So we carry out the calculations over here. So let's just copy the calculations from here. Do we need this input, enter the number? Should we need
You kind of cut out a little bit.
Can you guys hear me? Okay, so the question is, we copied the if structure from the previous code, the script file. My question is, should we copy this line as well, the input line?
No, because that's part of the function when you have the input.
Hang on, sorry, I don't hear you guys. Say again. Yeah.
Because that's part of the function, like what it does, you put the input in there.
We defined I as the input, so we shouldn't have to redefine it.
Exactly, I think both of you are right. It's the way you use the function file. So the beauty of function file is you don't really need to have that input line. It's not necessary. So let's see how we are going to use it if we don't have that input line. So let's save this. And as we know, whatever name you have assigned to the function name, it automatically pops up on when you are trying to save it under the MATLAB directory. So let's save it with that name. Otherwise it don't work. And let's now try to run this directly from here. It sees, it finds an error because it doesn't know what I is. So you don't run the function files like the way you typically would run a script file. The way we should run this function file is like this. So my sign is this name of the function. And whatever number you might want to check. So let's try out what is sine. So basically we are trying to replicate something like this. So instead of this sine function, we have developed a new function, which is this function, fall 2020, like 5, 4, 4. So once we try this, okay, my computer has frozen. Yeah. So once we assigned this number 10 to the function, the my sign was 1. And since I already have this as without semicolon, it did the output twice. So let's fix that. Let's save this again. Let's now try out a negative number. So we got my sign is -1. Let's try something else as well. Instead of assigning again my sign on this line, let's see what happens if we just use the function with the argument, just like we can use the inbuilt sine function from MATLAB. There as well, you get the -1, exactly like what would happen if we had been using the inbuilt sine function. We get the same output. So now we know how you set up inbuilt functions into MATLAB, and from now on you can keep on using this function instead of sine. Of course, these simple functions are already inbuilt in MATLAB, but this implies that you can set up any function and you can use it for other calculations. Any question on this one? And hence, this is the beauty of functions. You don't really need the input line, which you actually needed when you wrote it as a script, which is like for one-time use. Okay, so let's come back to the lecture. So I have this screenshot for the script file, the function file, and then I have discussed all different aspects of whatever we ran on the command window. So if you didn't follow the lecture, just go back into the PDF lecture notes as well. And all these things have been explained here, whatever we did. Okay, so this last problem is sort of like a way to figure out how we try to interpret something that's not given in the form of numbers. But as we know, on MATLAB, we always need to deal with numbers, and we need to tell the story that we want to tell MATLAB in the form of numbers. So this question is a movie rated R. So everyone purchasing a ticket needs to be at least 17 years old. Write a code that asks the user to enter their age and displays whether they are allowed to purchase a ticket. Also, the ticket printer will print a ticket when the variable print ticket is set equal to 1. So let's summarize what it says. So the age has to be entered into the machine. If the age is greater than 17, a set of operations will be done by the computer at the theater. If it is less than 17, a different set of operations. So let's try to write the code for this. So let's write just a script file. So clear all, close all, CLC. What should be the first input? The first input should be, because whatever we are going to do on this problem has to do with the age. So the computer would first ask you what the age is. So age is input, enter your age. Okay, so once that is done, now the computer would have the information on the age for the person. If age is less than 17, then you can ask MATLAB to carry out a certain set of operations. So the first operation might be display, you are too young. And the question actually tells you what the second operation is going to be, which is if the age is less than 17, then print ticket is 0, which means that the ticket won't be printed the way the code has been set up into the computer. Now, do we need an else, or can we directly go to else? Do we need an else if, or can we directly go to else?
Can we change the age to less than or equal to on the first if?
Yeah, but should we need to do that with an else if, or can we directly go to else? So
We can just do else.
Right. So if the age is less than 17, the only other option that's left is either it's equal to 17 or greater than 17. And we don't really need to tell MATLAB that. We can just go to else, and then we can just, you are allowed to go in. And then you can assign that the number 1 to the variable print ticket as well. And so let's save this code. So fall 2020 lect 5 code 5, and let's run this. So enter your age. If it is say 14, then you are too young. And then if I type print underscore ticket, that's 0. But now if I run it again, if I type the age as 20, you are allowed to go in. And then if I have type print ticket, it is 1. So this is how you reduce your problem into the form of numbers that would control some conditions, and conditions that you can tell MATLAB, which would determine which particular operations it's going to carry out based on checking the condition. So I hope this gives you a broad overview about how the if statements work. I have a little bit more complicated problem here, along with the code and some logic on the mathematical operation. You can go through this at home, and I have the code here as well. So you can just copy paste the code for this particular problem. So the homework has 3 questions. They're all due, as I said, on 14th September. And whatever we have here is related to scripts and functions. And I think there is, the 3rd question is on the use of if loops. Okay, any questions? The lab classes are going on. So if you don't get the Zoom link before your lab, you can directly email me or to the TA. Anyway, so see you guys next week.